In this video, we are going to see about losses in a transformer. There are two major components in a transformer, namely the magnetic core. So this is the magnetic core over which we have the coil. So there are two coils, primary coil and the secondary coil. So in the magnetic core, the losses that occur in a magnetic core is called the core loss or iron loss, and in the windings we will have copper loss. So we will see about the losses in detail. We will see about the different type of losses. There are four different type of losses in a transformer, namely the core loss or iron loss, which is again divided into two types, hysteresis loss and eddy current loss. So the core is made up of a magnetic material. So because of that, we have two core losses, two types of core losses. Then we have copper loss in the winding. These two are major losses, and we have dielectric loss which occurs in the insulating medium or like a transformer oil we use it. So in that some losses occur, we call it as a dielectric loss, and the other one is stray loss which may be due to the leakage flux. So these two losses are very small compared to these two major losses. First, we will see about the core loss. So in a transformer, we always give a AC supply. So the loss that occur in the magnetic core of the transformer when you give an alternating AC field is called the core loss. This is a magnetic material, and when you give an AC supply to that, the flux produced by this alternating supply is also alternating. So the core is subjected to magnetic reversal. Because of that, the core gets heated. So the loss that occurs in the magnetic core due to this AC supply is called the core loss. There are two types of core loss, hysteresis loss and eddy current loss. First, we will see about the hysteresis. What do you mean by hysteresis? So hysteresis is a Greek word meaning lagging behind. It means that somebody is lagging behind, or you take a car race, we can say the other cars are lagging behind this car. So we are lagging behind. Let us see what do you mean by hysteresis in a magnetic core. So in any magnetic material, we have this BH curve. So which gives the relation between the flux density and the magnetizing force. Magnetizing force is nothing but directly proportional to the current. So we give an alternating current to the transformer. So whenever you give an alternating current, an alternating flux will be produced. This flux linking with the core is also alternating. So because of this, we are getting this hysteresis. So you are giving H, you are increasing the H, the flux density will also increase till it reaches the saturation point. But when you decrease the H in the reverse, you are decreasing the H, it will not follow the same path. Instead, it follows a different path. So by the time H becomes 0, B is not 0. So you need to give more energy to bring the flux density to 0. Or we can say some energy is lost in this process of magnetization and demagnetization. Actually, we are giving an alternating field. So the core is subjected to an alternating flux. So that is called the magnetization and demagnetization. So when any magnetic material will have small magnets inside, or it is made up of small magnets which will have polarity north south north south north south. Polarity will be there. When you change this direction of magnetic field, this north will become south, and here you will get north. So it keeps on changing its position, and at one point there will be a lag in the alignment. So that lag will lead to heat in the magnetic core. We call it as a hysteresis loss. So hysteresis loss is the energy lost when the core is subjected to a changing magnetic field. So the area within this loop will represent the energy lost per cycle of magnetization. So hysteresis loss can be written by this expression. So where this one is called the hysteresis coefficient, B is the flux density, and F is the supply frequency, and V is the volume of the core. So this constant, Steinmann's constant, depends upon the type of material we use for the core. So that plays a major role in determining the efficiency of the transformer. So how to minimize this hysteresis loss? We have to use a core with the smaller hysteresis loop area, because we have seen that the area inside the loop represents the loss. So if you have a smaller loop, you will get low loss, and if you have a wider loop, you will get more loss. So always prefer high quality core material. So normally this cold rolled grain oriented steel will be preferred for high efficiency transformer. So you can see this is the CRGO steel. Next we will see about eddy current loss. Eddy current means it's a circulating current. This occurs in the core, that is some circulating current flows in the core. Eddy current got its name from the eddy current in ocean water, because in ocean water we can see these type of eddy currents. So when you give an AC supply to the transformer, the magnetic field is also current is sinusoidal, and the flux is also sinusoidal, and this flux is perpendicular to the area of the core. So because of that, a voltage will be induced, and this induced voltage will produce a circulator current if this circuit is closed. So eddy current is basically a circulating current. This current will lead to some losses in the core. That is called the eddy current loss. So it is normally I square R loss, because this core has very less resistance. It will be I square R loss will be there. So R is the resistance of the core. How to reduce this eddy current loss? So you can see here in the core, the area is more. So when area is more, the current is, the loss is more. So we can, instead of having a single solid core, you can have a steel laminated core. That is, thin laminations will be used. So you slice this into a small things, the area is reduced. Thereby we are reducing the eddy current. So finally, if you see the transformer, you can see thin laminations are there. Thin sheets will be there, and each one will be insulated from one another. So here you can see, when you have a solid core, it will be eddy current will be like this. When you have a laminated core, that is, in each part there will be eddy current, but the magnitude is very less. And the eddy current loss equation is given by this one. So this is the eddy coefficient, flux density, frequency, thickness of the lamination, and volume of the material. So in a transformer, the core loss can be given by hysteresis loss plus eddy current loss. So in a transformer, the flux is practically constant, because even if the load changes, the primary will change the current to maintain the flux practically constant. So when the load changes from no load to full load, the variation in the flux will be very less. So we can say the core loss remains almost the same at all loads. If you draw the curve between loss and the load, core loss will be almost constant. So core loss is also called as constant loss. Copper loss is the loss that occurs in the windings, in the transformer windings. So the windings are made of copper, so we call it as a copper loss. The copper loss is given by I square R. That is, whenever current flows through the windings, the winding will have some resistance. Because of that, we will get I square R loss. If more current flows in the transformer, more losses will be there. So we cannot limit I because it depends upon load. We have to limit the resistance. So copper loss is also called as a variable loss. So copper loss will occur in both primary and secondary. So we can say total copper loss is equal to primary current. I1 is the primary current, I2 is the secondary current. R1 and R2 are the resistance of the primary and secondary winding. What is the effect of copper loss? It gets heated because so you will get I square R loss will be there. How to reduce the copper loss? So copper loss is given by I square into R. I depends upon the load. So we have to reduce only R. So R we know R is equal to rho L by A. So by changing the area, we can change the resistance. It means that we can by changing the thickness of the wire, we can change the copper loss. So core loss, we have seen that core loss is equal to constant loss. So it can be drawn like this, and copper loss is a variable loss. So this is the no load condition and it is a full load condition. So as you increase the load, the copper loss will increase. Core loss can be easily found from the open circuit test because we have seen that core loss is a constant loss. So from open circuit test, we can get the information about core loss. But copper loss, we had to vary the load from no load to full load so that we will know the copper loss. For that, we can do a short circuit test and we can calculate the copper loss. Let us summarize what we have seen. The total losses in a transformer are core loss, copper loss, dielectric loss and stray loss. So core loss, there are two types, hysteresis loss and eddy current loss. Copper loss mainly depends upon the resistance in the windings. So it is I square R loss. And we have dielectric loss. It is due to the insulating medium of the transformer like transformer oil. And stray loss is due to the loss in the leakage. Loss that occurs due to the leakage flux. So if you like the video, do subscribe to Read Electric Vehicle channel. Thank you.